What if I told you can't know the particle's position and exact speed at the same time? Well, it's true, and this concept is emphasized by the Heisenberg uncertainty principle, which is given by this equation here. And so this equation says that the more precisely you measure a particle's position, the less precisely you can know its momentum. And this also works vice versa. But what does this actually mean? So if we look at this picture here, in this situation, in the top part, we accurately identify the position of a particle, but we can see since we accurately identified the position, the momentum vector is pointed in all directions, so we actually maximally don't know the momentum. And so likewise, in this picture here, if we find the exact momentum as pointing to the right, we can see that we very maximally do not know the exact position of the particle. But why does this happen? This is because particles, like electrons, behave like waves. So above represents the path an electron travels. A wider wave means we know the momentum well, but we know position not as well. And thus, in the wider part of the wave here, this is the possible positions, which means the particle can be at any part of this wave. And for a narrow wave, this means that we know the position well, but we don't know the momentum. So we can see here, since the wave is more narrow, we can identify the position. But since the wave is narrower, the direction the electron can be traveling in changes more constantly because of the wave being more narrow. The trade-offs can be illustrated by this diagram. So if it's a wider wave, that means that we know the position less, but we know the momentum more because the momentum is changing much less frequently. And vice versa, if we know the precise position more, that means that the wave is more narrow. And so we do not know the momentum as more precisely because it's changing much more frequently. One thing to note is that this is not a limitation. This phenomenon is not due to using bad measuring tools. This is a fundamental property of quantum mechanics. And so basically, to summarize, the uncertainty principle isn't saying particles are hiding information from us. It's saying nature itself doesn't allow both quantities to be perfectly defined at the same time. A bonus here, mathematically, the Heisenberg principle can be summarized by the following diagram below. And so you can pause the video and look here. This is a good summary of the mathematics behind the Heisenberg uncertainty.